The maintenance warehouse is often the most overlooked drain on a company's balance sheet. In many facilities, inventory is treated as insurance, but in reality, it functions as a graveyard for dead capital. Billions of dollars are frequently tied up in spare parts that sit on the shelves for decades, slowly deteriorating or becoming obsolete, while one critical component needed to prevent a catastrophic shutdown is nowhere to be found. In many facilities, inventory is treated as insurance, but in reality, it functions as a graveyard for dead capital. Millions of dollars are frequently tied up in spare parts that sit on shelves for decades, slowly deteriorating or becoming obsolete, while the one critical component needed to prevent a catastrophic shutdown is nowhere to be found. This is the inventory trap. It stems from a reliance on min-max levels, which are essentially statistical guesses often made years ago based on a manufacturer's manual rather than the actual physical reality of the plant. Managing a warehouse this way is the definition of physical guesswork. It assumes that every part has an equal probability of failing at any moment, which is a mathematical impossibility. The asset intelligence framework breaks this cycle by shifting from a just-in-case mindset to a strategy of risk-based inventory intelligence. To understand why traditional inventory fails, it is necessary to look at how parts are usually ordered. Most systems trigger a purchase order when a stock level hits a certain number. This approach ignores the condition of the asset. If a primary drive motor is currently operating in peak health with zero thermal stress and perfect vibration signatures, holding a $20,000 spare on the shelf is a waste of capital. The money could be deployed elsewhere in the business to drive growth. However, because most plants have zero visibility into the deterioration curve of the equipment, they choose to hoard parts out of fear. This fear is a direct result of information latency. When the physical state of the machine is unknown, the only logical response is to overbuy. But once the physical guesswork is removed, the warehouse can finally be synchronized with the actual physics of the flow. The core of this module is the transition to health-based inventory. This is where the PF interval, the time between a potential failure being detectable and a functional failure occurring, becomes a financial tool. In this system, the inventory software talks to the asset sensors. If a sensor detects an early-stage fatigue signature in a critical bearing, the system doesn't just send an alert to a technician. It checks the lead time for that specific part. If the lead time is 2 weeks and the physics show the bearing has 4 weeks of life remaining, the system calculates the Goldilocks zone for the purchase. The part is ordered so that it arrives exactly when the maintenance window opens. This is just-in-time reliability. It ensures that capital is only committed at the exact moment the physics of the machine demand it. Not all parts are created equal. In the asset intelligence framework, inventory is categorized not by cost, but by its impact on the default engine. A $10 sensor that protects a $1 million turbine is far more critical than a $500 pump housing for a non-essential line. The system utilizes a risk-weighted matrix to determine what must be held on site versus what can be managed through supplier agreements. By analyzing the critical path of production, the framework identifies the specific components that would cause an immediate, in full, on-time failure if they were to break. These parts receive the highest level of intelligence monitoring. By focusing the sensors on these high-risk areas, the operation can reduce the total volume held inventory by as much as 30% while actually increasing the overall reliability of the plant. Part 5. The financial recovery. When a facility removes the physical guesswork from its warehouse, the financial impact is immediate. First, there is a one-time cash flow injection as obsolete stock is liquidated or returned. Second, there is a permanent reduction in carrying costs, which include insurance, taxes, and physical space required to store parts. But the most significant win is the elimination of stockout downtime. In a traditional plant, the longest delays aren't caused by the repair itself, but by the wait for a missing part. By using strategic inventory intelligence, the part is always there before the failure happens. This isn't just about saving money in the warehouse. It's about protecting the 1.2 million contracts discussed in earlier modules. It is the final step in turning a chaotic mechanical environment into a streamlined, high-yield financial system. Part 6. Conclusion and action step. The challenge for this session is to walk into the warehouse and pick 3 high-value spare parts that have been sitting on the shelf for over 2 years. Look at the assets they belong to. Are those assets being monitored for health? If they are, and if the physics show they are in peak condition, then that insurance is actually a liability. It is time to stop guessing and start measuring. In the next module, the focus shifts to the brains of the operation. Module 12, Operations Copilot and AI Agents. This is where all this data is turned into autonomous action.